Hello guys and welcome to today's class. Today we will continue with our study of functions and we will go into the part number 2. So let's do it. What are the objectives for today? Today you will learn number 1 the definition of domain of a function and number 2 how to find such domain. So the idea for today is this, the domain of a function. That's all we will see. And before we continue, I need to state the following remark. In the remaining of the semester, when we talk about a function, we will mean a function of real numbers. Why do I say this? Because remember that a function was a machine, okay, that could take any type of input and give out any other type of input. Remember the example that I gave you about entering letters here and the function calculating the order of such letter in the alphabet. Okay, so we don't care about this type of functions. These are interesting functions for other type of mathematical studies, but for us, for this semester, we care about functions of real numbers, functions that only take real numbers here. I don't know, 3, 1 half, 0.5, minus 3 over 7, whatever, and they give out also some type of number, okay? We don't care about this type of functions. So unless I state otherwise, every time I say the word function, I mean a function of real numbers. So let's go into the topic. What is the domain of a function? Let's read. The domain of a function f is the largest set of all numbers in which the function can be evaluated without crashing. And again, this is not a technical definition, okay? This is just my wording. But sorry, in more technical terms, we say that the domain of the function f is the set of all numbers for which the function is defined. And as always, the way to understand this is by doing it, okay? You cannot learn to walk by reading the definition of walking, right? You have to walk. Okay, so that's what we're gonna do today. I'm gonna give you several examples of functions, and we are going to calculate their domains. I listed 13 examples. I hope we can get them all done. Okay, so grab pencil and paper, please. It doesn't have to be your notebook. Remember, I just need you to exercise because in the end you will solve the activity. Okay, in the PDF file. So take pencil and paper and let's do it. You won't need the calculator, but have it by your side anyways. Okay, so we are given this function f of x equals 2x plus 1, and they want me to calculate the domain of f. So what is this? How do we do this? Okay, look at this. The first examples are going to be a little too. There's going to be a lot of explanation, and in the last ones we can do them quicker. Okay. All right. So we have this function, and let me evaluate this function in say 2, in the value of 2 for x. So as we know, all we have to do is every single time we see the x by 2. How much is this? This is 5, right? So we say the following: f of 2 equals 5. F of 2 equals 5. The value of the function in 2 is equal to 5. Another way to say this is the value of the function in the independent variable, something that I forgot to tell you the last time. This is called the independent variable. The value of the function in the independent variable is equal to 5. Okay, so what about this? What I can say is the following, that 2, the number 2, is part or is in the domain of f. Okay, why? Because I can actually evaluate the function in the number 2. Okay, it gives me this value. For this number, the function gives me this output. Okay, so it behaved correctly. It didn't crash. The function when being evaluated in 2 did not crash. It gave me a well decent number. So we say that 2 is element of the domain of f. What about minus 3? If I evaluate the function in minus 3, what do I get? I get 2 times minus 3 plus 1. Calculate this quickly. This is going to be minus 5, right? So again, I can actually evaluate the function in minus 3 because the function gives me as output minus 5. So I say the following. Minus 3 is also part or is also element of the domain of f. Okay? So we are putting numbers inside the domain of f. But this process can go on forever, right? I mean, I could evaluate the function in many numbers and be putting those numbers in the domain of f, which is a set. It's a set of numbers, okay? So what are we gonna say? If you notice, we can evaluate this function in any number. It doesn't matter. Okay, I could evaluate this function in 0.1 and I'm gonna get a well decent number. I could evaluate this function in 1/2 and it's also gonna produce a number, a normal number. Okay, it's not gonna crash. So basically I can evaluate this function in any number x that I please. It doesn't matter which number. Every single time the function will give me a well defined number. So we say the following. The domain of f for this case is equal to the set of the real numbers. Okay, because any real number that I could put in here is gonna give me a real value, a well-defined value. Nothing weird is gonna happen, and by weird you're gonna understand what I mean in a moment. Okay, so the domain of this function, which is written in this way commonly, is equal to all the real numbers. I can put any real number I want in here, or I can evaluate the function in any real number. That's what this means. Example 2, g of x equals x squared plus x plus 1. Okay, same idea. I can evaluate this function in any number I want. Let's evaluate in 1/2, okay? This is going to be equal to 1/2 squared plus 1/2 plus 1, okay? And in the end, this will be 1/4 plus 1/2 plus 1, and g of 1/2 will give me in the end, how much is this? This is 3/4 plus 1, one integer and 3/4 or 7/4, right? Yeah. So this is the value of the function when we evaluate such function in this value in 1/2. So we say that 1/2 belongs or is an element of the domain of G. Okay, why? Because we could evaluate the function in 1/2 and it produced this output. Now again, I don't want to waste a lot of time doing a lot of evaluations. If we notice, this function can actually be evaluated also in any number that I could put in there, g of -1, g of 1/7, g of the square root of 2, whatever. All of these things are gonna produce normal numbers. Okay, they're gonna produce a number actually. Okay, nothing weird is gonna happen. So again, we also say that the domain of G is equal to the real numbers, all the real numbers. I can evaluate this function in any real number and nothing weird is gonna happen. And again, you will understand what I mean by weird in a moment. Example 3. The function h of x equals the square root of x. And pay attention to this requirement, okay? Or to this caveat. Consider only the positive root for h to be a function, because remember, if you look at this, you may say, let me evaluate h in 4, and that's going to be equal to the square root of 4. But I could have two possible values, right, for this operation. I can have h of 4 equals 2, or h of 4 equals minus 2 because these two numbers are the square root of 4. Okay, so if I did that, this wouldn't class h wouldn't classify as a function because for a single input it would give me two different outputs. And remember that the definition of function doesn't allow you to have two different outputs for two or more outputs for an input. Okay, but if we only stick to consider only positive roots, then h can be a function. Okay, so we say, nah, let's ignore the negative the negative side of this. That sounded philosophically. Let's ignore the negative side of this square root, and so h is now a function. Can we do that? Sure, no problem. Remember that in mathematics you are the creator. You can do whatever you want. Okay, well, not I didn't mean that. uh, you can create things as long as you respect logic, as long as you don't uh, um, create contradictions and so on. Okay, you're not allowed to do anything you want. You have to respect the rules of logic. Okay, so h of 4 equals 2. And so what do we say? We say that the number 4 is an element of the domain of h. Okay, now what about evaluating h in 9? That would be the square root of 9, which is 3, which is also a good real number, a simple answer. And so we say that 9 is part of the domain of h. Why? Because we could evaluate the function h in 9 and it produced a well-defined output. Okay, now, right now I'm going to start telling you about what I meant by weird in the other two examples. What if we evaluate this function in minus 1? What if we want to do this? Let's say, let's evaluate h in minus 1. Let's see what's going to happen. We're going to have the square root of minus 1. And as you know, as you've been told, without any real explanation, I understand, because that comes later, unfortunately. This is not a real number, okay? This is not something that we can calculate in the real numbers. There is no real number such that when multiplied by itself 2 times will produce minus 1, okay? There is no such real number. Okay, so this operation or this question, what is the square root of minus 1, doesn't have an answer in the real numbers. Okay, so what we say is this. We say that we cannot evaluate h in minus 1. We cannot evaluate the function h in this particular value. So what we write mathematically is this. Minus 1 does not belong to the domain of h because we cannot evaluate the function h in minus 1. Or another way to say this is because the function h is not defined in this number. Because of this, because we are trying to calculate the square root of a negative number which doesn't have an answer in the real numbers. Okay, and the same is going to happen every single time you want to evaluate the function in a negative number. Can you see? Also, minus 2 is not part of the domain. Also, minus 1/4. I cannot take the square root of any negative number in the real numbers. Okay, so all of these numbers are disqualified to belong in the domain of h. And what about the general statement? What can we say? Okay, we can say that we can evaluate this function in any number as long as that number is not negative. How do we write that mathematically and in a very short and economical way? We say this. The domain of h is equal to all the real numbers except, okay, this is a symbol of a minus, and it's read that way, except or minus. Look at this. This is the way in which we're gonna do it. These are keys. Let me draw it in a better way. Except all the numbers x such that x is less than 0 or x is negative, right? This means that x is negative. So let me read that again. The domain of H is equal to all the real numbers, that's fine, all of them, except those numbers x such that x is less than 0. Because if we want to evaluate this function in any number less than 0, like we tried, this is going to crash. That is what I meant by the word crashing. And so this is the solution to this example. Okay? Let me tell you another way in which we mathematicians, crazy people, like to write this. We like to use symbology a lot because it makes things easier, right? It shortens everything. Another way to write this is this way. The domain of H equals the real numbers except all those numbers x such that, with a vertical stick, this means such that x is less than 0. So there you have a new symbol for you. Okay, this is read such that. So you are compressing two words in a single symbol. And another way to express exactly the same thing is this. Minus or except all those numbers x such that, okay, another weird symbol, such that x is less than 0. So all these three things mean exactly the same thing. Don't be scared about symbols. Symbols are a way to make your life better, okay? Because you don't write that much. I love it because it allows me to write complex ideas in like quickly, okay? All right, let's move on. Example number 4. We have f of t equals the square root of t minus 3. Remember, you don't have to have an x always here. Don't get married to x's. Okay, so what about this? Again, it's the same idea. We can give this function any value of t as long as in the end the radicand is not negative. Because if I have all of this being negative, I'm going to be calculating the root of a negative number and the function is going to crash. So I need this radicand to be either 0 or greater than 0. I repeat, this radicand has to be 0 or greater than 0 in order for this function to be defined. So how can I calculate the domain? Okay, in this way. What I'm going to do is this. I'm going to write t minus 3 is greater or equal than 0. Okay? When I write this is called an inequation. And what I'm asking mathematics is, what are those values of t such that t minus 3 is greater or equal than 0? And by solving this inequation, I can find those values. So let's solve it. An inequation is solved similarly to an equation. Okay, many of the steps for solving normal equations with the equal symbol hold for inequations, but there is just an extra requirement which I'm going to show you in a moment. Okay, so t minus 3 is greater or equal than 0, and then I can add 3 in both sides, and this is going to happen, right? Then t has to be greater or equal than 3. So this is the answer that mathematics is giving me. My question was, what are those numbers t such that t minus 3 is greater or equal than 0? And mathematics is telling me, oh, okay, t has to be greater or equal than 3 in order for this to be greater or equal than 0. And it makes sense, right? Because if you give this expression any number t greater or equal than 3, what are you going to get? Let's give it 3. You get 0, right? let's give it 4. You get 1. Let's give it 5. You get 2. So all numbers t greater or equal than 3 will give you that this expression is greater or equal than 0. Okay, so we can evaluate this function f in any number t as long as that number t is greater or equal than 3. Okay, I can give any number t here as long as this number here is either 3 or greater than 3 in order for this function not to crash. Okay, so let's write the final answer. What is the domain of f? The domain of f is all the real numbers. You can give it anything you want except those numbers that do not stick to this requirement. Okay, all those numbers that do not satisfy this requirement. So how do I write that? Except all those numbers t such that t is less than 3. Okay, because in this case, for all these values the function crashed, so I want to accept them. I want to kick them out of the domain. I don't want them. And any t that is less than 3 will give you a negative radicand and you will have problems. Okay, so this is the domain of the function f. Another one, example 5, s of n equals the square root of 2 minus 4n. Same idea. What I want is this to be greater or equal than 0 in order for this radicand to be able to be calculated. Okay, all of this has to be greater or equal than 0. So let's ask that question to mathematics. For what numbers n do we have that this is greater or equal than 0? For what numbers? Okay, let's solve this inequation. They're called inequations, inequaciones, inequations. Okay, so let's solve this inequation. First, I'm going to subtract 2 from both sides, and I'm going to get this. Minus 4n is greater or equal than minus 2. You know, just like we normally do in equations. And then here comes the new trick that I told you in the example before. Now, I want to multiply by minus 1 in order to convert this term to positive. Okay, but if you want to multiply or divide by negative numbers in an inequation, what you have to do is this. You can do it just fine, just like you can do it with equations. But if you do it, you have to flip the direction of the symbols. Okay, this is greater or equal, and if I multiply by a negative number of this inequation in both sides, I need to flip the direction. I'm not giving you a demonstration of that. Okay, I cannot give you the demonstrations for everything. That would make the course extremely cumbersome. So you have to do it. If you are interested, look it up. Look at why this happens, and congratulations for being curious. Okay, and so now let's do it. Okay, minus 1 times minus 4n is 4n less or equal than this, which is 2. And let's continue over here. We're going to write the same inequation. And then we divide over 4 in both sides. Since 4 is a positive number, I do not change the direction of the inequation. You only change the direction, like in here, from here to here, when you multiply or divide an inequation by a negative number only. So what do we get? We get 2 over 4, and so we get n is less or equal than 1/2. Okay, so for all numbers n that are less or equal to 1/2, this will be okay. This can be evaluated for all these numbers. So any number that doesn't respect this requirement is out of the domain. Okay, so let's actually write that answer. The domain of s is equal to all the real numbers except those numbers n that do not respect this requirement, So the domain is all the real numbers except those numbers n such that n is greater than 1/2. Because if n is greater than 1/2, then n would not be complying to this requirement, and so we want to kick those numbers out. If you try to evaluate this function in any number n greater than 1/2, this thing is going to crash. Let's quickly give one of those examples, okay, in blue. So suppose you want to evaluate s in a number n greater than 1/2. For example, 1. 1 is greater than 1/2, right? So s of 1 is equal to the square root of 2 minus 4 times 1. And so s of 1 is equal to the square root of 2 minus 4, which is equal to the square root of minus 2. And there you crashed, okay? Because you're trying to evaluate a square root in a negative number. And the function crashes, okay? Red alarm. You cannot do this. So that's a counterexample. So as long as you stick to numbers less or greater than 1/2, you will be safe. Example number 6. T of x equals the cubic root of x minus 1. So what do you think about this? Now look at this. We have a cubic root, okay? We don't have square roots. We have a cubic root. Try to evaluate this in your calculator. Try to evaluate this function in minus 8. What do you get? You get the cubic root of minus 8 minus 1, and then you get the cubic root of minus 9. And calculate that root, please. The cubic root of minus 9. Let me do it myself. You're going to get minus 2.08. Okay? So cubic roots can be evaluated in negative numbers. Okay? That is not a problem because they are cubic. If you multiply this number 3 times by itself, you will actually get this number or close to this number. Okay? So in the case for cubic roots, we don't have to worry about anything. Okay, we can evaluate these functions in any number of x and nothing weird is gonna happen. Okay, this function t will not crash. So t, the domain for t, is actually all the real numbers. Okay, so don't you think that every single time that you see a root, you have to be cautious about the domain? No, the only problem arises when you have in here even numbers, either 2, the square root, or the 4th root, or the 6th root, and so on. For other numbers, for odd numbers, the domain will be the real numbers, all the real numbers, okay? We don't have to be worried about this. Example 7. F of x equals the square root of 2x plus 4 over 7 minus x. So let's ask that question again. For what numbers x is all of this greater or equal than 0? So let me ask that question. For what numbers x does this expression is greater or equal than 0? How do we know? How do we answer that question? By solving this inequation. So let's do it. First, I'm gonna add this and this. Okay, I'm gonna subtract them. Sorry. So I'm gonna do that by getting an equivalent fraction. This is the same as minus 7x over 7. I'm producing an equivalent fraction to x, right? In order to be subtracted with this other fraction, because now they have a common denominator. So I'm gonna continue over here. We're gonna have 2x plus 4 minus 7x over 7 greater or equal than 0. Okay, let's simplify the numerator. We have minus 5x plus 4 over 7 equals, sorry, greater or equal than 0. And then we have the following. Let's multiply both sides by 7, just like we do with normal equations. We're gonna get this, right? I multiplied by 7 in both sides. Okay, then let's subtract 4 from both sides. Next, let's multiply by minus 1 in both sides, and you're gonna get this 5x. You flip the direction because I multiplied by minus 1. And finally, we divide over 5. So look at all of this. Okay, so my question was, for what numbers x is all of this greater or equal than 0? And mathematics gave me this answer. Mathematics told me, if you take the x to be less or equal than 4 over 5, then 4 fifths, then all of this will be greater or equal than 0. So any number x that fulfills this requirement will be part of the domain. And in any number x that doesn't satisfy this requirement will be out of the domain. Okay, so let's write the domain. The domain of f is equal to all the real numbers except or minus all those numbers x such that do not respect this requirement. And how can I write that? Such that x is greater than 4 over 5. Because if a number x has this property that is greater than 4 fifths, then it would not be respecting this requirement. Okay, and so this is the domain of the function f. Okay, if, I encourage you to do some experiments on your own later today. For example, now that you know the domain of f, try to confirm that this is in fact the domain. Try to give it any number uh, um, which respects this domain. Okay, for example, any real number such that is below 4 fifths or actually 4 fifths, and you will see that this function will give you a normal value. It will be defined. But if you give it any number inside this set, the set that we are kicking out of the domain, for example, if you give it the number 10, 10 is greater than 4 over 5, right? If you give this function, if you evaluate it in 10, this function is gonna crash. Okay, so do that type of experiment, those confirmations at least once or twice for every function, and you will you will start to understand what we are doing. Okay, let's do one more, I think. Okay, example 8. K of x equals the square root. So again, we have an even number, we have to be cautious. The square root of 1 minus x raised to the square. Look at this. Pay attention to what we have as a radicand. Look at all of this. Remember, when we have a square root, we have to worry about not having negative radicands if we want to calculate the domain. But I ask you the following. Could this radicand possibly be negative? 1 minus x, all of that raised to the square. What sign does this number have for any possible x that we give it? Look at this, it's raised to the square. So all of this number will always be positive, no matter what x I put in there. It doesn't matter, because in the end, I'm going to have all of this thing raised to the square, and it's going to come out positive. Okay, so the radicand in the end will always be positive. So we have nothing to worry about. We can give x any number, positive or negative, and in the end, let me erase everything. In the end, all this radicand will be positive because of this little guy in here. So this guy saved us from doing any calculation. Okay, so we say that the domain of K is all the real numbers. Okay, we don't have to worry about having negative radicands because of this guy. I hope you understand what I'm saying. Example number 9, g of t equals 1 over t. Again, we can give g any value and it will produce a decent, well-defined value. For example, g of 2 is 1/2, g of minus 5 is 1 over minus 5, and so on. Okay, I can give t any value except which one? What do you think? If you said 0, you were correct. Why? Because obviously, if I try to evaluate g in 0, what's going to happen? I'm going to have 1 over 0, which is a forbidden operation in mathematics. Okay? I don't know if I've told you this. If I haven't, let me know so I can explain to you why 1 over 0 is why it's not possible to carry the operation 1 over 0. It's very interesting to know why this cannot be done. So the function g cannot be evaluated in 0. But that's the only number that we have to kick out of the domain, okay? Because for any other number, this expression will give you a good, normal, simple, well-defined number. So the domain of G is all the real numbers except the number 0. That's it. That's the only number that we want to kick out of the domain. This is the only number that is prohibited. Example 10, h of a equals 1 over 2a minus 12. So again, you can give h any number you want, as long as that number that you're giving doesn't produce a 0 here. Okay? We cannot have a denominator equal to 0 in this type of functions. So for what value a, let me ask mathematics that question. For what value of a is this equal to 0? So the way in which we set that question is this. I'm asking a question, okay? For what value of a is all of this equal to 0? And let's solve it. Okay, for a equals 6. That's my answer. Okay, for a equals 6, this denominator will be 0. Okay, let's confirm it. 2 times 6 minus 12 is equal to 12 minus 12, which is 0. You see, for this number, you get 0 in the denominator. So that's the only number, number 6, that you have to kick out of the domain. Because if you try to evaluate the function in that number, what's going to happen is you will have this and you will have this, and the function is going to crash. Okay, and so you want to eliminate this number from the domain. So let's go into the answer. The domain of h equals all the numbers, all the real numbers except the number 6 only. This is the only number that will be kicked out of the domain. This one, w of v equals 5 minus v over 4 minus v squared. So same question. I'm going to ask mathematics the question. For what numbers v is this equal to 0? because if this is equal to 0, my function is going to crash. So let's answer that question. I write down 4 minus v squared equals 0, and I solve that equation in order to get the answer. So what do I get? I get 4 equals v squared, and then I get v equals 2. uh, I'm gonna get two solutions, right? V equals 2 and v equals minus 2, because 2 to the square is 4 and minus 2 to the square is also 4. So in this case, this is an example of a function which cannot be evaluated in two possible numbers. If you give this function the number 2, you will have 5 minus 2 over 4 minus 2 to the square, and this is going to be equal to 3 over 0. So the function crashes in this number, but it will also crash in minus 2, because we will have 5 minus 2 over 4 minus 2 to the square, and this is going to be equal to 7 over also 0. Make sure that all of this is also equal to 0. Make sure. Okay, so w is also undefined in this number. Okay, it crashes in this number. We cannot evaluate the function w in this number and also in this number. So let's write the domain. The domain of w equals all the real numbers except the number 2 and the number minus 2. This is the way to write it down. Okay, let's move on. Example 12. We have the function u of y equals 2 over the square root of 2 minus y minus 4. Understand that this minus 4 is not inside of the radical sign. Okay, so same idea. We cannot have this to equal to 0. We cannot have denominators equal to 0. So I ask that question, for what values of y is this expression equal to 0? For what values? And all I do is solve that equation. Let's solve that equation. We add 4 first, and then we square both sides. So when I square this, the square root is going to disappear, right? When I elevate this to the square. So I'm going to get 2 minus y equals 4. And then I'm going to continue over here. And then we're going to have the following. Oops. Minus y equals 2. I subtracted 2 from both sides, and then I'm going to multiply by minus 1. So we will get this, y equals minus 2. So if you give this function the number minus 2, if you input this value in here, you will have a 0 in here, and so the function is going to crash. So the domain for u is all the real numbers except the number minus 2, because if I try to evaluate this function u in this particular value, all of these will become 0 and the function is going to crash, and we don't want that. And finally, example 13, f of x equals all of this. Okay, I'm gonna leave this as homework, okay? But you have to, I'm just gonna give you the sketch. It's the same idea. For what values of x is all of this equal to 0? For what values of x? So you need to solve this equation. For what values of x is this expression equal to 0? You're gonna solve that equation, which is a quadratic equation, right? You're supposed to know how to do that already from first semester, and you will get two possible answers, okay? One and two. two possible answers because any quadratic equation has two answers. And let's call this A, and let's call this answer B. Okay, because I'm not calculating them, I cannot tell you any specific number, so I'm gonna call them A and B. So for A and for B, this is 0, and so these two numbers are going to be prohibited in the domain of F. So we would write the domain of F is equal to all the real numbers minus the number A and the number B. Okay, you solve this equation on your own. You solve this problem on your own. Basically, you want to find these two values. Okay, so that's an introduction to the topic of domain. It's more complex than that. Okay, for more general functions, but for the functions that we will be looking at in this semester, that's how this works. What you have to do is basically the following. These are the takeaways. Okay, this is what you have to understand from today. For most elementary functions, the domain is the set of all real numbers, except those which cause either divisions by zero or negative radicands of even roots. Remember, only even roots. When you have a function like this, f of x equals the cubic root of x minus 1 over 2, whatever, okay, you don't have to worry because this is odd. But when you have a function like this, mm, okay, something like this, then you have to worry. Then you have to do the reasoning that we did before in order to exclude or kick out those values of x that will produce a negative radicand in here. Okay, so that's basically the only two types of the only two types of crashes that our functions will go into, either division by zero or negative radicands of even roots. Memorize this, burn this into your brain. Even roots. Okay, so that's it, guys. That was longer than I expected, as always, and that's it for me. I hope you have understood, and see you later.